Okay, so today we are going to start the last topic of O-levels chemistry, that is polymerization and polymers. So, when we talk about polymers, so polymers are basically large or macromolecules which are made up of many small molecules, and those small molecules are called monomers. What does mono means? Mono means single. So actually the whole monomer means single unit. And poly means so many, and polymer means so many units. So what this make you to understand that there are so many single units, and all of these units join together to form a one large big macromolecule called polymer. Is this understandable to all of you? Oh, okay, Laiba. Yes, is this clear to all of you? Okay. Now, in the other word,
Yes.
you can consider a monomer and a polymer like this. For example, if we say one brick or a one cement block is a monomer, and when we join both of thousands of these bricks, we are going to build a house, right? So that house is a polymer. So in the same way, many small same type of molecules join together to form a big large molecule, which we call polymer. Okay, and the reaction by which a polymer is formed, it's called polymerization. Polymerization of ethene. So ethene is a monomer, right? And we are going to polymerize it, means we are going to join thousands of ethene molecules, and as a result, when so many ethene molecules join, we get a polyethene. So it's very easy. You have to just put a poly in the prefix, a polymer is formed. Is this clear?
Yes, sir.
Okay. Now, so polyethylene is a plastic, and when we talk about plastics, so plastics are made from a polymers. What are the characteristics of plastic? They are durable, they are water resistant, and they are good at shock absorption. So these are the some typical properties of plastics. Now, first we are going to discuss addition polymerization. So polymerization, as we have discussed earlier, a reaction in which polymer is formed is called polymerization. Now, what is addition polymerization? A reaction in which monomers join together to form a polymer only. Okay, a reaction in which monomers join together to form a polymer only. For addition polymerization, monomer must have carbon-carbon double bond. So that is the condition for a small molecule or a monomer to do addition polymerization. If it has a carbon-carbon double bond, then it can form addition polymerization, addition polymer. And sometimes examiner asks you about the addition polymerization. So we explain it in this way: a chemical reaction in which monomers joins to form polymer only and nothing else is formed, then that kind of a polymerization reaction is called addition polymerization. Is this understandable?
Yes, sir.
Okay. Now, if you see, what is this? This is a ethene molecule, right? There is 1, 2, 3, 4, 5, 6, 7, 8, 9 ethene molecules. So they are just 9 over here, but in actual, not just 9, actually thousands of ethene molecules like this arrange themselves in such a way. And then what will happen? The double bond between in a molecule is broken down, this double bond, and as a result, these molecules starts to bond with each other and form a very long chain like this, as you are observing at the bottom of the screen now. So there are numerous ethene molecules, and it is a part of a polyethene chain, a polymer. And if you see here how many repeat units are there, this is a one repeat unit, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So there are 9 repeat units over here. Is this understandable?
Yes, sir.
And see,
Yes, sir.
here are double bonds. When these double bonds are broken, they the carbons, the carbon of the one monomer bonds with the carbon of the other monomer, and as a result, the whole structure continues. And if you see on both the ends, we show the empty bonds on both the ends, which means that this structure is actually continued over here, and in the same way, this structure is continued over here, and there are many multiple units which are continued on the left and right of this part of a chain. Is this clear? Okay, just give me a minute, please. Assalamu alaikum. Till here, is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now, if we have to show the equation for this kind of polymerization, we'll show like this. We draw one ethene molecule and we put a N over here. N means number of the moles. So it can be 10,000, right? Or it can be 19,000, or it can be any other number in the thousands. So what happened? All of them got their double bond broken like this, if you see over here, and have a single bonds on both the sides. And on the right side, instead of the whole molecule, we just make a one repeat unit, and then we enclose it in the bracket like this, where the single bonds on both the sides are cutting through those brackets, and we put a N over here. So N over here means whatever the number of moles we have used, these all number of moles are joined together, and we are just showing one single unit. Is this clear?
हाँ सर, clear.
Yes, Khatija, Laiba, Manahil, and Mustafa.
Yes, sir. Clear.
Yes, sir.
Okay. Now, see, if the examiner asks you to draw one repeat unit, so see, it's a polyethene, so we just draw this thing with no brackets, so it's a one repeat unit. If the examiner asks you to draw three repeat units, so see, by this way we make three repeat units, 1, 2, and 3. Is this clear?
जी sir.
Yes, sir.
Now we have a chloroethene. When as you see that ethene is forming a polymer called polyethene. So when we have a chloroethene, it is going to form a polymer polychloroethene. So what is over here? See, if one of the hydrogen is substituted by chlorine, so this compound becomes chloroethene. And here we get the polychloroethene. So if we have to show the equation again, we'll do the same thing. See, like this. Now we made a single bond. We put the groups whatever on the two carbon atoms, and then we make the empty bonds, enclose it in the circuit, in the bracket, and then put an N over here. Is this clear? And see,
Yes,
here
sir.
we got one repeat unit, and here we got three repeat units. So it depends what examiner asks you, you have to write in that way. Is this clear?
Sir, हमें कैसे पता चलेगा कि वो bracket में मांगना चाह रहे हैं आप?
In bracket, when we have to show the whole molecule, then we will keep it in the bracket. Otherwise, if they ask you to draw one repeat unit or three repeat units, you will do it by this way. Okay.
Okay, sir.
Okay. Now, see, the monomer is propene, and it is turning into polypropene. So if you see the structure, propene is this. Now, that is very important to understand over here, because in the previous examples, we have only two carbons, but here, if you see, there are three carbons. So what we are going to do, when we are going to show the equation of the polymer, or we have to show a part of the polymer or the repeat units, what you are going to do, you are going to just put these two carbon atoms. If you look at the carbon atom which is on the right of the double bond, how many hydrogens it has? Yes.
Two hydrogen.
Two hydrogen.
Two hydrogen.
One hydrogen like this and the other hydrogen like this. Is this understandable?
Yes, sir.
And the carbon which is on the left of the double bond, what groups it has?
Four hydrogen and one carbon.
No, not like this. this carbon directly bonded to a one hydrogen, and on the other side it is bonded to a CH3. So we put the groups which are on the double bonded carbon like this on above of them and on below of them. We do not make any group like this over here when we have to show the structure, when you have to show the polymer. Is this understandable?
Yes, sir.
जी
So now what I will do, I'll put a n over here, and for the equation, now I make the double bond a single bond, put the empty bonds on both the sides, keep the groups as they were earlier, like this, then enclose it in the bracket and put the n in the subscript. Is this understandable?
यस सर हमें मतलब वर्टिकली रखने होते हैं ना
Yes, only
Addition
the
cross
double bond, the
bonded.
carbons which have the double bond stay in the horizontal, and the groups which are bonded to these two carbons put vertically upward and downward to those carbon. Is this clear?
Okay.
Okay.
Yes.
A minute, please. Okay, is this clear to all of you? Now have a look at the equation. As I have told you, we just keep the carbons which have a double bond in the middle, and the rest of the groups which are bonded to these two carbons are placed vertically upward and downward. And then if you have to draw the one repeat unit, you will do like this, and you have to draw the 3 repeat units, you will do like this. Is this understandable?
Yes, sir.
Okay. Now, if we polymerize butene, we are going to form polybutene, right?
Yes, sir.
Or would be polybutene. So if you see butene is if I draw butene, isn't it like this? A CH2 having a double bond CH, CH2, CH3. Is this clear? Now, if I have to make the equation, what I'll do, I put the two carbons having a double bond in the middle. Now tell me the carbon which is on the left of the double bond, how many, to which groups it's bonded?
Two hydrogens.
Two hydrogens, so I put a one hydrogen above and one hydrogen below. And if you look at the carbon which is on the right of the double bond, it is bonded to a one hydrogen, and the other side it is bonded to a CH2, CH3, which is combined and written as C2H5, or you can write CH2 and then CH3 in both way. So that's how we arrange a monomer to show the polymerization. Then when I have to show the polymer, I'll keep the single bond, put the empty bonds on both the sides, and keep the groups as they were, as I have drawn initially, and then enclose it in the bracket like this and put the n over here. Is this understandable?
Sir, but show all of the bonds and the atoms भी कभी-कभी examiner पूछ लेता है ना?
But for polymer they don't ask.
Okay.
Is this clear? So see, that's how we do for a butene and form a polybutene. Now, if you have a butene, so see, if butene is CH3, CH, double bond, CH, CH3. So if I have to show the polymerization, I will make the double bond carbons in the middle. The carbon which is on the left of the double bond has a hydrogen and a CH3. And the carbon which is on the right of the double bond has a hydrogen and a CH3, right? So there are n number of moles. and then C, 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 H, H, CH3, CH3, and then we put a N over here. So it's a polybutene, and this one is a polybutene. Now, so 1 repeat unit, 3 repeat units. Then in the similar way, butene is this, and we have to make the polymer or draw the polymer. We will keep the monomer like this, and by the help of this, it's very easy to form the polymer. And then if you make the polymer, it's very easy for you to make 1 repeat unit, 2 repeat units, or 3 repeat units. Clear? Is this clear to all of you?
Yes, sir.
Okay, if any one of you has any confusion, please ask. Okay, now phenylethene, that is called styrene as well. So when it will form a polymer, we do the same thing. We just put a poly before it, polyphenylethene or polystyrene. So it has this structure. A carbon has a C6H5 group. So we keep that group as it is, just make the double bond, turns the double bond into a single bond and keep the empty bonds on both the sides. And this C6H5 can be written like this as well. So in either way, sometimes if the examiner make this structure, so there is no need to confuse because you have to do the changes over here only, right? So instead of the double bond, you put a single bond and then draw the empty bonds on both the sides. Is this clear?
सर जब भी ये क्वेश्चन आएगा तो इसमें एक डबल बॉन्ड तो बनवा देंगे ना कोई सा भी.
If they give you the monomer, sometimes what they do, they show you this kind of a structure and ask you to draw the monomer. So if you see this, you have to identify the repeat unit. If you see, this whole thing is repeated again, and this whole thing is repeated again. So this is a 1 repeat unit. So for a monomer, I'll repeat this 1 repeat unit. What I do, I just don't put the bonds on right and left of this. Instead, what I'm going to do, I'm going to put the double bond. If the examiner show you the chain of the polymer and ask you to draw the monomer.
Okay, sir.
Okay, let me see if the question I heard in the, I think I had, when we are doing the past papers, we will find a question like this. Let me show you.
सर हम पास्ट पेपर क्वेश्चंस अटेम्प्ट कर रहे हैं.
See, like this. I'm just showing you how the examiner can ask the question. See, they have shown you this structure and they ask you to draw the monomer. So I've identified this is the repeat unit. I have drawn it over here and put the double bond. So it depends. Examiner can do both the things. Either examiner give you this and ask you to draw this thing, or if examiner, as you see over here, given this and ask you to draw the monomer. Is this clear?
Yes, sir.
Okay. Now, after this, we have a condensation polymer. Okay. Condensation polymerization. It is a chemical reaction in which monomers join to form a polymer and a small molecule such as water or HCl is released. So see, this is the difference between condensation and addition. If you recall the addition again, when a monomers joins together, they join to form only a polymer, nothing else has been made. But in condensation polymer, it's just like a reaction of to form ester, esterification, where carboxylic acid and alcohol joins to form a ester as well as a water. So that's why we call it condensation. In the same way, the condensation polymerization is a reaction in which when a polymer is formed, along with the polymer, a small molecule such as HCl and or water is released, then that kind of a polymerization is called condensation. Is this clear?
Yes, sir.
So there are two types of condensation polymers. One is a polyamide, and this is the amide link where the carbon double bond O is bonded to a nitrogen. So if in the polymer chain we have a multiple of this link, that's why we called it polyamide. And that is a polyester which has a ester link. Just give me a minute, please. Okay, so this is a ester link. A carbon double bond O has a bond with the single bond O, and both sides there is a carbon chain. In the same way, both sides there is a carbon chain. And if the polymer chain has a multiple of these links, then it is called polyester. Is this clear to all of you?
Yes, sir.
Okay. Now, both are almost same. The only difference is this link. So there are numerous amide links. That's why we call it polyamide. There are numerous ester links. That's why we call it polyester. It is made from two type of monomer. One monomer have a two carboxylic acids group, and we call it dicarboxylic acid. Or instead of dicarboxylic acid, we have a two acid chloride like this. If you see, this is the structure which we will not show. Instead of that structure, we use to show the box. And in that structure, we have a two carboxylic acids. Or instead of this, we can use this one as well, which we call di-oil chloride, or we call it diacid chloride, where there is a C double bond OCl groups in it. Is this understandable? Yes.
Yes, sir.
Okay. Just give me a minute, please. Okay. So in the same way, that same kind of a monomer can be used to prepare polyester as well. A monomer having a two carboxylic acid group on both the sides, and the other monomer has a two acid chlorides or acyl chlorides on both the sides. So we can use any one out of these two. And the box over here, it is actually represent the rest of the structure of the molecule. There is a possibility that it is just CH2 in between, or there is a 8 carbon 8C8816 long chain. So it doesn't matter. We just need to show it with the box, whatever in the middle of these two functional groups. Is this clear to all of you?
Yes, sir.
Okay. Now the other monomer that we used for a polyamide is a diamine, where two NH2 groups. NH2 is called amino group. So there are two NH2 groups are bonded on both the sides of the monomer. We call it diamine. And for ester, for a polyester, the monomer that we use is called diol. Here it is diamine. So the first type of a monomer is same in both polyester and polyamide. And the second monomer is different. For polyamide, it's a diamine, and for polyester, it is a diol, where the two OH groups are present on both the sides. Is this clear?
Yes.
Okay. Now have a look. If you see this thing, see one dicarboxylic acid, one diamine, one dicarboxylic acid, one diamine. So why we kept this box shaded and this box unshaded? It means that there is a possibility that the number of carbon atoms in both the monomers are different. That is possible. Okay. So one dicarboxylic acid, one diamine, one dicarboxylic acid, one diamine. So what happens from the carboxylic acid? OH is released, and from diamine, H is released. In the same way, OH and H is released, OH and H is released, H is released from here, OH is released from here. And now see, this carbon bonds with this nitrogen bonds with this carbon bonds with this nitrogen. And as a result, see, there is a long chain of a monopolymer is formed, which is a polyester, and the hydrogen and the OH releases to form water. So see, water is formed along with the formation of a polymer, and it's a part of a polyamide, and that polyamide is a specifically called or generally called nylon. And see, there is a one amide link, there is a second amide link, there is a third amide link. In the same way, there is one more, there is one more, and then these amide links are continued in the whole chain. That's why it is polyamide, and specifically this one is a nylon. Is this clear?
Yeah, sir.
Okay. Now have a look over here. Dicarboxylic acid, dialcohol, dicarboxylic acid, dialcohol. So H from alcohol and OH from carboxylic acid are removed, and they all remove to form water. And as a result, this carbon bonds with this oxygen bonds with this carbon bonds with this oxygen bonds with the carbon which is of the other monomer on its right side, and this carbon bonds with the oxygen of the other monomer which is on this side, and as a result a very long chain is formed. And in this chain, see, there are multiple ester links, so that's why it's called polyester, and specifically it is called PET. And why it's a condensation polymer? Because a large polymer is formed, and along with that water is also released. Is this clear?
Yes, sir.
Now if you see the repeat unit, isn't it the repeat unit is this part? Because from here a repetition is started, right?
G.
So if they ask you to draw one repeat unit, we'll draw like this. And over here, if you see the repeat unit, it starts from here and then it's over here. And from here, the repetition is again starts. So one repeat unit over here and one repeat unit over here. The polyester is called PET and polyamide is called nylon. Till here, is this clear to all of you? If any one of you has any confusion, please ask.
सर नायलॉन प्लास्टिक होता है ना?
A sort of a plastic, but not actually plastic, because if you see, nylon is used to make the ropes for the hiking, nylon is used to make the nets for fishing, and sometimes nylon is used to make the clothes like jackets and the outerwears. And polyester, PET is used to make the plastics.
Okay, sir.
Now, if you see, as we have discussed initially, that instead of dicarboxylic acid, we can use di-oil chloride. So if instead of these, if we have a di-oil chloride, so it means we are going to have a Cl on both the sides, right? Instead of a OH. So if this was the case, then instead of 4 water, we are going to get 4 HCl over here, and we are going to get 4 HCl over here. So see, again, it's a condensation because a small molecule is forming when the monomers joins to form a polymer. Is this clear?
Yes, sir.
Okay.
सर ये repeat कर दिया sir.
See, if instead of carboxylic acid, you use di-oil chloride. So then the chlorine is the one which is removed, right? So instead of water, we get
Yes, sir.
So again, it's a condensation polymerization because a large molecule, a polymer is formed and as small molecules are released. So it depends which small molecule is released, either HCl is released or either water is released. Okay.
Okay.
And sometimes examiner can trick you, instead of HCl, they can give you any other halogen, right? So if whatever the halogen they give you, you will put that halogen over here, and again, it's a condensation polymerization. Okay, Manahil, Laiba, Fatija, Mustafa, if you guys have any confusion, please ask.
No, sir, clear है अभी तक.
Okay, so nylon is a polyamide. It's a man-made polymer, means synthetic polymer, and it is prepared from condensation polymerization. In the same way, PET is a polyester because there are so many ester links. It's a man-made, means synthetic polymer, and also prepared by condensation polymerization. Okay, now next thing we have a proteins. It is a natural polymer and it is a polyamide. It is prepared from monomers called amino acid. And see, the last paper that we did yesterday, they have asked you to draw the basic or the general structure of the amino acid. Let me show you if it's there now. That's what we are going to do today. Yes, see over here, see. Draw the general structure of the amino acid monomer used to make protein. So it's this. So you have to remember this thing, that the amino acid has a carbon, and that carbon has a one bond with the carboxylic acid, second bond with the hydrogen, third bond with the NH2, and fourth bond with the R. R means it can be a different side chain. There are multiple structures R has. Is this clear? Now, if you see the difference, here the monomer has two functional groups on both the sides, but if you see both the functional groups are same, isn't it? And the other monomer also has two functional groups, but both the functional groups are same. One monomer has two NH2 groups and the other monomer has two carboxylic acids, right? But if you see in a amino acid has two different groups. One is a carboxylic acid group and one is a amino group. So NH2 is a amine group and COOH is a carboxylic acid group. So that's why we call it amino acid, because it contains amine and acid. Is this understandable? Now, if you see the structure of a protein, in protein, the repeat unit, if you see the repeat unit in the structure is this, because from here the repetition is start, right? Yes, is this understandable?
सर ये जो R बॉन्ड हुआ है इस कार्बन से बॉन्ड हुआ है RNH, ये देखें.
Yes, RCH. This is a carbon which bonded to four groups: NH2, R, H, and COOH. What is your question?
सर मुझे स्ट्रक्चर ऑफ प्रोटीन समझ नहीं आ रहा.
What is the problem? You have to understand. This is structure.
Yes.
Okay, see what we did. We considered this as a box. Okay.
Okay, sir.
Now, if you see from here, hydrogen is released. From here, the OH is released, right? And from this nitrogen, the C double bond of the other monomer is joined. And from this C double bond O, the N of the other monomer is joined. Now see, if I put a H and if I cut this all thing down and I put a OH, so see, isn't it this thing where this thing is represented by this box?
जी sir.
Sir, so proteins form water as well?
Yeah, obviously, because if you see from here, the hydrogen is releasing and from the OH is releasing, and that's why this carbon is bonding with the nitrogen of the other monomer. Is it clear now? But the only
Yes, sir.
difference is that see, over here, the repeat unit is a long and it also contains the amide link in it. Because if you see from here, the repetition is a start. But if you see over here, the repetition just start from here and the repeat unit is very small. Is this clear?
Yes, sir.
Okay. Now we have a plastics. Plastics are polymer. Mostly plastics are non-biodegradable, which means they are not decomposed by bacteria. So that's why their disposable becomes a very big problem. There are three ways by which we can dispose of plastics. We put them in the landfill sites. So as they are not biodegradable, so they stay there and they do not decompose. That's why those landfill sites filled up and we need more landfill sites to dispose them. Is this understandable?
Yes.
The other way is we put them in the ocean. As a result, they get accumulated in the ocean, and when they accumulated in the ocean, they affect and harm marine life. That is the problem. Third is we can dispose of by burning, but we burn them, the toxic gases are released, and when the toxic gases are released, it can cause the air pollution. Right?
Sir, ये plastic fossil fuel से बनता है ना?
Yeah, you have seen that plastics are made from the alkenes, the carbon-carbon double bonds, obviously, which are obtained from the fossil fuels. Okay, now PET, a polyester is a degradable and can be converted back into monomers. And by the reaction by which we convert them into a monomer is called hydrolysis. So hydrolysis, a chemical reaction in which a polymer is broken down into monomers by the action of an acid or an alkali. So what we do, we put the polymer, we either add acid or a base and then we heat it. On heating, what will happen? The linkages which were made to join them from those linkages, they broken down. And as a result, you see the monomers again formed. See, if this bond, let me show you, if this bond is broken, you will get one structure C double bond O box C double bond O, and the other structure O box O. So what happens? That water is being added, so the carbon is positive, so the OH group is being added to the carbon, making it dicarboxylic acid, and H group is being added to this, make it diol. So that's what happened in the hydrolysis, and the hydrolysis is done for the polyamides and the polyesters. Addition polymer cannot be hydrolyzed. Okay. So in the same way, we hydrolyze the polyamide, and on hydrolysis, it also turns into monomer, into its monomers, like diamine and dicarboxylic acid. Is this clear? And then, if we want to make the polymer, we again polymerize these monomers to form polymer again. Okay. So here are the few questions, and it's very easy. They ask you to draw the structure of nylon over here. So see what we do, nylon is a polyamide. So instead of this oxygen, we have to put the H everywhere. Then see the structure of the nylon is made. Now, if you see, they ask you to define addition polymerization. So I have told you in which monomers join together to form a polymer only and nothing else is formed, then it's addition polymerization. For example, if they ask you to draw its monomer, so we identified this is the repeat unit. So what we will do, we draw this one repeat unit over here, and then put the double bond in the middle. So that becomes a monomer. Okay. Now they ask you the condensation polymer. So the which polymerization reaction in which monomers join together to form a polymer and releases small molecules such as water or HCl. Now they have asked you to draw the one repeat unit. So if you see, this is the repeat unit. This whole thing is a repeat unit, and here it's repeated again. We just confirm it that what is the repeat unit, and we put this repeat unit over here. But instead of this repeat unit, if they ask you to draw the monomer, if here they ask you to draw the monomer, so what I do, I put a H over here and I put a OH over here, then it would be the monomer, because it's a condensation polymerization, right? They have mentioned you over here that it's a condensation polymerization. Till here, is this clear?
Yes.
Okay, so we are done with the syllabus. Now we are going to continue the classes in the night, and today probably we have a class at 8 for the past paper. Okay, and tomorrow we will do it at around 9:15.
Sir,
Yes.
plastics are polyamide.
Plastics are usually addition polymers. That's why they are non-biodegradable. And only PET is the plastic which is a biodegradable, which is a degradable. And it's a polyester, not a bio. Polyamides are nylon and protein. Normally,
Okay, sir. Sir, एक question था past paper से.
You can send me that question. I will discuss. Okay. Yeah, probably tomorrow, Laiba, the class will be at 9 or 9:15.
सर
Yes, Khatija.
सर ये 4 पे जो क्लास होती थी ये अब हुआ करेगी?
If you guys have any queries, then I can do this class. Otherwise, we will do only past paper class.
Okay, sir.
And why you were not joining, Khatija, the past paper class? I think Manahil joined
Sir,
sometime.
मैंने कुछ ज्वाइन करे थे, कुछ नहीं किए थे. वो क्लैश आ रहा था ना दूसरे सब्जेक्ट्स का, तो उसका सिलेबस भी कंप्लीट नहीं हुआ था, इसलिए.
Okay. Okay, what is the question?
Sir, I've sent it.
Where is the question? I have opened it. It's
Sir,
a
ये पहला
titration.
part समझ नहीं आ रहा.
It's a titration, it's not polymer. If you are asking in titration, state the name of apparatus used to transfer 25 centimeter cube of dilute lemon juice into the conical flask. So for a 25 centimeter cube, and when we are adding something in the conical flask, initially that is always done by the pipette. And it's a paper 4 question, if I assume, right?
Yes, सर मुझे B समझ नहीं आ रहा.
Okay, don't, you have to take the differences. They have given you all the values. You will take the differences. You will able to fill the third row. And then in the third row, when you get the differences, check the values. Which two are very closer, you are going to put the tick mark beneath them, because these two are the best results. We will do all this in after 3rd of May, because you have a paper on 14th May, right? Paper 4.
Yes.
So after 3rd May, we are going to do the paper 4 only, okay?
Okay, sir. Thank you.
Okay. So see you everybody in the next class. Take care. Goodbye. Allah Hafiz.
Allah Hafiz, sir.